Hello everyone, welcome back to another video. So today we are going to discuss editorial for weekly contest 436, and as you can see I was able to solve first three problems. Almost I'm very close to solving fourth problem, but I was not able to solve it during contest, so we will not discuss the solution for that question also. So my rank is 500. That's because of these two penalties, I guess. But one of them is silly mistake and one of them is logical mistake, I would say. So if I would have improved it, I would have only improved by one penalty, not more than that. And this was a interesting contest, I would say, because the third and fourth problem are not so standard. Uh, so solving them requires, they are more CP oriented problems, I would say. So let's just start with first problem. So in first problem we are given an n cross n square matrix of integers. Now what we need to do is the diagonals in bottom left triangle, including the middle diagonal, they need to be sorted in non-increasing order. That means decreasing order, and the diagonals in the top right triangle should be sorted in non-decreasing order. So for example, this diagonal, this is, let's just see first sample test case. The diagonal which contains 7 and 2 are sorted in non-decreasing order, so they are replaced with its increasing order, that is 2 7. Similarly the middle diagonal, now middle diagonal is also considered in bottom left triangle, and that needs to be sorted in non-increasing order. So 186 in non-increasing order would be 861. So the whole diagonal gets replaced by 861. 95 remains 95 because it is already in non-increasing order, and 4 and 3 remain same because it is a single element itself. So this is a pretty simple question, I would say. Why is that? Let me give you one very basic observation in this type of questions. Whenever you are processing a diagonal, let's say this diagonal, so this middle diagonal, so each diagonal would have a starting point and there would be an ending point and all the elements on diagonal. Now consider this starting point, let's say this is x comma y. Now its next element in the diagonal would be x plus 1, y plus 1. So x increases by 1, also and y also increases by 1. Similarly, x plus 1, y plus 1's next uh, adjacent element in that diagonal would be x plus 2, y plus 2. So in each change or transition, x value increases by plus 1 and y value increases by plus 1. This is the I would say optimized or most simple transition which you need to consider when you are processing a diagonal. That uh, moving towards plus 1 in both x and y direction until we reach any end or we go out of the matrix. So if we start from this as starting set, we will go here, and when we go out of the matrix we stop processing. So this is the main observation, not observation, but in this is a way to process a diagonal. I just explained how to process the diagonal very easily. So first of all, also For this specific question, all the top bottom left triangles, so all the bottom left triangles start would be this would be a bottom left diagonal, this would be also a bottom left diagonal, and the middle diagonal is also considered in bottom left triangle. Now this all these elements would be the start of diagonals which are present in top right triangle. So these are all bottom left and these are all top right. So top right, all the diagonals starting from these elements would be sorted in non-decreasing order, and this would be sorted in non-increasing order. So let me show you the code for this. So first of all, I'm processing uh, top right top right triangles diagonal, which start from which are 0 1 0 2 and this goes to 0 m minus 1. So x, for x coordinate I have fixed, and y coordinate is ranging from 1 to m minus 1. So here I'm starting those values, then I'm iterating over that diagonal and putting all the elements in another vector b, and the transition is x plus plus y plus plus. Now I have sorted that array b, and I have restarted the diagonal processing from x equal to 0, y equal to I, but this time I'm inputting a of x of y equal to b of j, because after sorting it, it would be non decreasing order, and then according to that order we will put one element there. So this was to process top right. Now this is to process bottom left. In this case, our y coordinate will remain say 0, but x coordinate will iterate go from 0 to n minus 1. So again same processing, but in here we are sorting the b array and reversing it again. So sorting it in reverse order, and then again putting them in the each diagonal. In that diagonal, in the order, in the non-increasing order. So this was the first problem, pretty simple. Most of the first problems are either brute force or implementation. This is the second problem. I think this has 4 points, but this can easily be 5 points if they would have increased the constraints here or made the constraints uh, very close, I would say. So in this question, we are given a groups element array and an elements array. Now what we need to do is we need to assign one element to each group based on the following rules. An element j can be assigned to group I if groups of I is divisible by element of j. Now if there are multiple elements that can be assigned, assign the element with smallest j. And if no element satisfies, we just assign -1 to that element, to that group. And we need to return an assigned vector where each index is the element chosen for group I. So simple. Let's just see the first sample discuss. So 8 4 3 2 4 is our groups vector, and elements is 4 comma 2. Now 8 for first group we can assign both the elements because 8 is divisible by 4 and 2 both. But when there are multiple elements that can be assigned, we assign the smallest index j. So here out of 0 1 we will assign 0 because it is smaller. Again for 4 we can assign both 0 index 1 index. but we here also we assign 0 because it is the smallest index. Next, for 3 it is -1 because none of the element in elements is divisible by 3. For 2, only one possible answer there is only one index satisfies the our condition, the first index element. So here one is one is pushed to our vector, and finally for 4 both of them are divisible. So the first one, which is the smallest index which is divisible by 4, is at position 0. So 0. So this is our answer vector. You can go through this and try to understand it more better if you don't. So first of all, we are given groups A0, A1 up to AN minus 1, and let's say elements, it's E0, E1 up to EM minus 1. Now for each element from I equal to 0 to I less than n, what we need to do is we need to find A of such E of j such that A of I mod A of j is equal to 0 and j is smallest possible value. So brute force approach is iterate over a groups array, and then for each index iterate over elements. So brute force would be I equal to 0, I less than n, I plus plus, and then iterate over j equal to 0, j less than m, j plus plus. If a of I mod b of j, e of j equal to 0, we push j into our answer. Our answer for this variable is j, and initially answer is -1, and we break because we only need one. Once we found, we break. So this is a brute force, and its complexity would be of n cross m. Now this is not allowed obviously because n and m both here is of order 10 to the power 5. So n cross m would go up to 10 to the power 10, so which will give you really. Now what can you do to make this more optimize this? Let's say we are iterating over array n and we find all of its divisors because uh, let's say e of I mod e of j is equal to 0. That means e of j is a divisor. So instead of going this way, what we do is we find all the divisors of a of I. Let's d1, d2, let's say these are its divisors. Now for each divisor, what if we check if this divisor is present in array E, and if it is present, what is the smallest index at which this is present? Let's say this was divisor 0 was present at J1, divisor D1 was present at J2, and divisor K was present at JK. Now there might be possibility where this is not present. In that case, it would be nothing. We won't consider it. But if they are present, our answer for ith group would be minimum of J1 comma J2 comma up till JK. So all the indices for each divisor we find the smallest index where it is present in E. If it is not present in E, we will ignore it. And from all the divisors, which was the smallest index? That would be the answer for group I. Now the complexity here would be, so we are iterating over n and we are finding divisors. Now to find divisors, it's complex. Most optimized approach has a complexity of root mx. Mx is the number itself. Let's say not root mx but root a of I. So we are iterating over n and for finding divisors it would be a of I. Now maximum value of a of I is 10 raised to power 5. So 10 raised to power root 5 and n is 10 raised to power 5. So 10 raised to power 5 into root 10 into 10 raised to power 2. I break it into 10 into 10 raised to power 4. 10 raised to power 4 comes out of square root and this remains. So this is approximately 3 into 10 raised to power 7, which is very close to TLE, I would say. But it works here. So this is the ideal solution. I think there might be better solution. I'm not sure, but this is, if it is for 4 points, then I thought this is the solution. And the constraints, the test cases are generated in such way that they are not very close to TLE. So uh, I just wrote this solution. So let's move to code. First of all, I'm storing each element's first index in a map. So I'm iterating over vector E, and whenever I find a new element which is not inserted in E of I will mark its index I. So if there was 2 before at index, let's say 1, and there was 2 at index 9, whenever uh, I found 2 first, then only I will mark its index as 1. Here I won't even mark it because I already have a same value before in the elements, and whenever 2 is required we'll always pick the smallest index. Then after that I have declared a result variable to store all the answers. Now I'm iterating over array groups array, and then I'm iterating over all the divisors. So from 1 to j plus plus until j into j, j into j is less than equal to I. So square root of a of I. Don't use like this sqrt. It might give error in some cases where there is precision error given by sqrt. So always use j into j less than equal to a of I. Now if uh then if j is divisor, if a of I mod j is 0. Now if j is divisor, also a of I divided by j is also an divisor. So in both cases we take answer with minimum of its minimum index in E array for both the divisor j and a of I by j. Now if answer is equal to int max, that means we don't find there is no divisor in array E for a of I, then we make answer equal to -1 and push it to result variable. So this was second problem, pretty easy I would say. Now moving to third, I found this quite interesting. There might be two approaches to solve it. I will explain the approach which I use, but there is definitely a DP approach here. But I found pre-computational greedy logic more easier than DP. So here what we are given is a string consisting digits, and now what we need to return is number of substrings of s such that it is divisible by their non-zero last digit. Now this is a very ambiguous statement. I will explain you why. Now a substring is continuous non-empty sequence of characters within a string. So what we need to do is we need to find number of substrings such that it is by. Now we will see one example. So 12936. Now let's write all the substrings. First is 1, 1, 2, 1, 2, 9, 1, 2, 9, 3, and 1, 2, 9, 3, 6. Next is 2, 2, 9, 2, 9, 3, 2, 9, 3, 6, 9, 9, 3, 9, 3, 6, 3, 3, 6, and 6. So these are all the substrings. I wrote them in such way that the starting character is constant. So here 1, 1, 2, 1, 2, 9, 1, 2, 9, 3, 1, 2, 9, 3, 6, 1 is common. Here 2 is 9, 3, 6 in such a way. Now out of all the strings we need to count if that substring is divisible by its non-zero last digit. So 1 is obviously divisible by 1, 2 is also obviously divisible by 2. So all the substrings of length 1 will always count to my answer. Now 112 is divisible by 2, 129 is divisible by 3 because 9 plus 2 plus 1, 12. 12 is divisible by 3. Divisibility test of 3, so it is divisible by 3. No, no, this is 9, right? We need to check if it is divisible by 9. This is not divisible by 9 because sum should be divisible by 9. We need to check if this number is divisible by its last digit, which is 9. So this is not. 1293 is divisible by 3 because sum here is 15. Divisibility test of 3. 9 plus 2, 11, plus 1, 12, 12 plus 3, 15, 15 mod 3 is 0. So this is. Now this is divisible by 6. Now divisibility test for 6 is it should be divisible by 2 and it should be divisible by 3. Now 2 is divisible because 6 last element is 6 and 3 sum should be uh, divisible by 3. So this is divisible by 6. 29 is not. 293 is also not. 2936 11 no. 93 is divisible by 3, yes, this is also true. And 36 is divisible by 6. So total 4 plus 1 5, 5 plus 6, and answer is 11. So here answer is 11. Now why this is at least I found ambiguous is, let's say a substring is 120. Now its last digit is 0. Now according to this condition we need to find number of substrings divisible by their non-zero last digit. Now non-zero last digit here according to me it would be 2. So what I need to do is check if the substring is divisible by 2. So I assumed this type of uh, logic, but this is not what they are saying. According to them, when the last digit is 0, no substring is considered as one of the possibility. So we just ignore when the last digit is 0. But this was pretty ambiguous. I tried to find answer based on this sample test case, because 570 is not considered anywhere. Only 0 is also not considered. So we need to take care of that. And n is obviously 10 raised to power 5. So brute force would not work. So what can be possible approach for this? First of all, main idea here is the last digit. Whatever we need to do is with the last digit of substring. So let's try to fix that last digit. Fix that last digit. Now, how to fix it? So fixing it means, let's say I'm at index I and its last digit is X. Now, how many substrings are there before uh, which are ending with X, which are ending at X, such that they are divisible, which are ending at index I, not X, which are ending at index I, because there can be another X and index would be I plus J. So we just need to check how many substrings are there which are ending at index I and they are divisible by X. Now X can be 1 to 9. When X is 0 we are just ignoring it, so don't consider it. Now X can be 1 to 9. Now try to write cases for each of them. Let's say X is 1. Then my answer would be all the substrings that are at ending at I. Here also we don't need to worry about leading zeros. So 001 also can be one substring. So in this case, all the substrings which are ending at index I. When X is equal to 2. Now divisibility test of when 2 divisibility test of 2 is the last digit should be divisible by 2. Now here it is already 2, so we don't need to check it. So here also all the substrings which are ending at I would be the contribution of index I. Now when X is equal to 3, then the sum of digits should be mod 3 must be equal to 0. Now let's say this is 3, this is some d1, d2, and this is some f1, f2. Let's say these are the digits. Now if this is let's say assume that d1 plus d2 plus d3 mod 3 is 0. We have assumed it. Now this is where prefix some logic to picture. So d1 plus d2 plus 3 mod 3 is 0 if this substring is divisible by 3. So can I say that d2 plus 3, so this is my prefix mod 3 minus f1 plus f2 mod 3 must be 0, because this minus this, not exactly mod 3, whole mod 3 should be 0. Then we can also say that f1 plus f2 plus d1 plus d2 plus d3 mod 3 would be equal to f1 plus f2 mod 3. So for index I, this is prefix of I mod 3. What we need to do is we need to count its frequency. We need to count such j's such that prefix of j mod 3 is equal to prefix of I mod 3. So uh, what we can do is I we can iterate from left to right. Whenever we meet an element 3, what we need to do is we need to take total sum, take its mod. Now this would be required for all the elements before it. We want its mod 3 should be equal to that current values mod 3. So what we will do is we will take a map and store all the prefix sums mod 3, and whenever we come across 3, we will add the frequency in our answer variable. So this is the concept of prefix sum when we are checking if there is an continuous substring which has total sum with some mod equal to 0. Then what we do is we take prefix mod and we check its frequency of prefixes before it and how many of them are equal to the required mod itself. So this is a pretty standard prefix technique, I would say. So we take prefix and it take its mod 3, then we find its frequency for all the prefixes before the ith element. Here we can also include I, then we don't need to worry about uh, the singular element, single length substring. So first we add 3 to our current when we meet index 3. When we meet an element 3 at index I, then we add the frequency of current mod 3 in our answer. That way we get number of substrings which has sum equal to sum divisible by 3. So this is the case for when x is equal to 4. Now when x is equal to 4, this is the case for x equal to 3. Now we will do for x when x is equal to 4. X is equal to 4, the divisibility test is pretty easy. What we need to do is we need to get two indices, so current index and its previous index. Let's say it is the digit at I minus 1 is y and digit at I equal to x. So the number would be y into 10 plus x. So this is 3, this is 6, then 3 into 10 plus 6, 36. In that way, this if this is equal to 0, then all the substrings are my answer. If this is not equal to 0, then only one substring which is starting at index I and ending at index I would be my answer. Now and when x is equal to 5, the divisibility test says when last digit is 5 or 0, our answer the number is divisible by 0. Already the last digit is 5, so all possible substrings are divisible by 5. Now when x is equal to 6, what we need to do is we need to check if the number is divisible by 2 and 3. Now this is already divisible by 2 because the last digit is 6 and it passes the divisibility test of 2. Now we only need to check the divisibility test for 3. So we can use the same logic of x is equal to 3. Now x is equal to 7 is the tricky part. Let's ignore it for now. It has different logic. Now x is equal to 8 is when last three numbers, so I minus 1, I minus 2. So this the number formed by these three digits should be divisible by 8. If it is, all the substrings are divisible by 8. If it is not, then we will check for I minus 1 comma I and add answer plus plus and answer plus equal to 2 if this is divisible. That means one would be this substring, other would be the whole two length substring. And if this is also false, then answer would just increase by 1. That is the substring and starting and ending at index I. Last is when x is equal to 9. Here all the all the total sum of digits should be divisible by 9. So we can implement same logic as 3, but uh, same logic as 3. The only difference is the mod value here would be 9, not 3. In 3 mod value was 3, here mod value would be 9. So implement same logic as 3, just change the mod value. Now the only case which is remaining is x equal to 7. Now for the divisibility test of 7 is tricky, I would say. So let's say we need to check 707 is divisible by 7. It is obviously, because this is just when we divide you will get 101 and remainder 0. Now according to divisibility test, how do we check it? So we take its last digit, multiply it with 2, so 2 into 7, and subtract it from its remaining digit, so 70. We subtract from so from 70 we subtract 2 into last digit, so this comes out to be 54. Now the remaining value, if it is equal mod 7 is 0, then answer, then this number is divisible by 7. If it is not, then it is not divisible by 7. So this is the test for 7. Now the difference in this and all above is that all above logics can be implemented in prefix manner. So moving from 0 to n minus 1. Only 7's logic needs to be implemented while going n minus 1 to 0. Now how is that? Let's say this is the index 7. Now this is x, y, z, and this is d. So let's say we need to check if d7 is a number and it's divisible by 7. So what we need to do is we need to check if d into 10 minus 7 d into 10 into 2 mod 7 is 0. Now we can ignore this 2 into 7 because it is already divisible by, so it is already divisible by 7, so we don't need to check it. So what we need to do is basically we need to check is d into 10 is divisible by 7. Instead of this we can just say that d7 mod 7 is 0. So if this number formed by this substring is divisible by 0, then so d7xyz, so this is the suffix number, so this suffix number, this mod 7 minus xyz mod 7 and its whole mod 7 would be equal to d7 mod 7. Now d7 mod 7 is 0, so what we need here is dz d7xyz mod 7 should be equal to xyz mod 7. Now d7xyz and xyz both are suffix numbers. So we move from n minus 1 to 0. In 3 and 9's logic, we are taking sum of digits. But here what we take is the number itself. Now, how the you might say that the number would go around 10 raised to power 5 because n is the n is maximum 10 raised to power 5. So how can we do this? So here we will use binary power. So to find, we don't exactly need this. We what we need is mod 7. So a raised to power b mod 7 is what we are required. Now to find this exponentiation with mod, there is a binary power formula, and this can be found in log 2 of b. So this is a divide and conquer type of method. To find a raised to power b, what we find is a raised to power b by 2, a raised to power b by 2, and take its square. And this goes to a raised to power b by 4, a raised to power b by 4 in such way. So we can find this digit mod 7. We can find this digits mod 7. Iterate from n minus 1 to 0. In suffix map, store mod 7 values. When we and only when the only we will only store suffixes where its previous element is 7. Let's say xyz, and there was this digit, let's say 9. Now this can this and this was d. Now this cannot be a suffix because the suffix should be after the 7 itself. Then only the 7 as a last digit would be considered and added to my answer. So only suffixes mod 7 would be added to the answer, or it would be stored when its previous element is 7. I will explain it more in while explaining you the code. But this is the main logic. For 1 to 9 it is pretty simple prefix logic except 7, and for 7 it is more trickier, I would say. And I think there are very less solutions of this type of logic because most of them used uh, DP, but I used this vague logic. But let me just explain the code. So first, this is the comments which I wrote for each divisibility test. Then I declared two maps. One is MP3, MP9. Now the empty substrings can have its mod value would be 1, and they also need to be considered. So I'm initializing them with 1. Now this sum stores sum of digits till I. Now I am iterating over 0 to n. If s of I equal to 1, all are the answers. S of I equal to 2, again all substrings is added into answer. If s of I equal to 3, then what we add is sum mod 3 based on our logic from MP3's map. In MP3 map, we are storing uh, prefix sum mod 3, so only access MP3. If s of I equal to 4, then take last two digits. If its mod is mod 4 is 0, answer all the substrings, else answer plus plus the only last digit. Now if the ith element is first in index itself, then answer would increase by only 1. Now if s of I is equal to 5, all the substrings. If s of I is 6, all the substrings which are divisible by 3, because it is already divisible by 2, we only need to check if it is divisible by 3. S of I equal to 7, ignoring here for now, because they need to process in perspective of suffix, so they are ignored. If S of I equal to 8, then same logic as 4, but 3 digits are considered. And if S of I is 9, same logic as 9, but sub mod 9 is taken, and from map MP9. And else it's 0, then we just ignore it. So after each iteration, I am updating sum mod 3 in MP3 with 1, sum mod 9 in MP9 with 1. So here we handled all the cases where last digit was from 0 to 9 except 7. Now for 7, I have declared a map MP7. There is a current variable which is storing the current number, current suffix number, and CNT I'm not using it. So first of all, if S of I is 7, so current index is 7, then what I'm doing is the current number which was after 7, so XYZ, I'm adding its mod 7 in my MP7 map. Now what I will do is, let's say the XYZ is my current number. Now my current, after moving towards left, DXYZ should be my current number. So I can break it like this: D into 1000 plus XYZ would be new current. So current would be D into 10 to the power 3 plus previous current value. Now 10 to the power 3 can be found by binary power. Now this can go up to 10 to the power n. So, and its complexity would be log 2 of n max at because this power would be max n. So I'm finding that digit, taking its this digit is n minus I, how many exponent value. So what is its degree, then taking its 10 raised to power 3 value, and also take its mod. We don't need to find its exact value, what we need is its mod value. Then I will multiply it with the digit itself, S of I minus 0, and take its mod with 7. Now my current value would increase by this value and take its mod again. And when I'm at that position, what I will do is I will increase my answer with MP7 of that current value 7, current value mod 7. I think this is kind of an overkill for this problem. DP would have been easier solution, but I came across this solution faster, so I wrote it. Till this prefix logic, it is easy, I would say. Only the logic for 7 is a lot difficult to process, I would say. So just go through code, try to write cases if you don't understand. I tried my best, but I think this is that type of question where intuition based logic is more understandable than standard logic. So write cases and go through this code and try to connect both the logics, and you will understand this question and solution. Now fourth one, I will give you a hint. This is binary search problem. Binary search plus game theory, I would say. We fix what is the minimum value and how many moves, how many times the score should be increased at index I. We pre-compute it and run a optimized game theory algorithm. and check if number of moves is less than equal to m. If it is, then that middle point of our binary search can be one of the answer. If it is, we move to right. If it is not, we move to left. That type of logic. I am just working on the logic for the game theory algorithm. Most is the optimized way to minimize the number of moves. That logic. I think this is a very close logic. I just need some improvements here. I will be able to solve it without looking at editorial, I think. This was a good contest, I would say. The third problem is not that standard, so there are very less solves for this. So this was a good contest, I would say. And I guess that's it from my side. Thank you for watching.